Okay, so what we're going to do in this clip is just try to give an explanation as to how and why the optical isomers originate. So again, what we've got here is the ethanol molecule, but this time we've drawn it in a three-dimensional way, which hopefully starts to illustrate the planar nature of the carbonyl group. We've got the carbonyl group pointing upwards within the plane of the page here, and then we've got the hydrogen disappearing into the background and the methyl group coming toward us. But this is a trigonal planar structure, so even though the diagram doesn't necessarily show it, that bond angles, all of the bond angles are 120 degrees. We've just kind of twisted it so that we're looking end on down the planar molecule. And what we can do is, we won't do the mechanism this time, but what you can then see is that if the nitrile group were to come in from this side of the molecule, then this would eventually create a situation whereby that's now become the hydroxide, but then the nitrile group is here with the hydrogen still going away from us because we have to maintain the stereochemistry of that central carbon, but then we have the methyl group coming towards us, whereas in the other example, or the other situation which is possible, if we had the nitrile group coming from the other side of the molecule and attacking the carbonyl from the other side of the plane, then this would eventually create its own corresponding molecule, whereby this time the nitrile would be on this side, and as we saw in the previous example, the chirality of that molecule is now defined because these two molecules, molecule 1 and molecule 2, are now optical isomers of each other. They're now no longer superimposable, and so we now, as we say, because of attack either above or below the plane, we've drawn left and right, but from either above or below the plane of that carbonyl group, it can attack in a 50% probability on both sides, so that it's equally likely to attack on both sides, which means that when you have a mixture of isomers 1 and 2, you have an equal amount, and so the mixture that you will then obtain is what's called a racemic mixture, whereby you have equal concentrations, equal contributions of both optical isomers, or both enantiomers as they're also called, both in the isomer 1 case or the isomer 2 case, 50-50 contribution from both, leading you to a racemic mixture of both optical isomers.